Hello, this is Tad Radzinski. I appreciate all of you joining today. I've pretty much dedicated my life to focusing on sustainability and changing our current systems in order to make the Earth a more sustainable place for us and future generations. And a huge piece of this commitment to sustainability that I have is education. It's one reason I created the blog series. It's also another reason I do a lot of teaching in various universities. And I do appreciate you all getting on today because our focus today will be the ongoing series of recognizing risks, identifying opportunities, succeeding in the green marketplace. And we're going to be talking more today about the cost of carbon. So I have a short presentation that I'm going to run through. And then what I'd like to do is I think the most productive means of doing these webinars is to get people's questions. So I plan to talk for about 15 to 20 minutes. And then I'll be taking questions which will allow you to ask specifics about maybe something you're doing in your organization or about something that I covered that I might be able to answer specifically that I think will help everybody that's on the webinar today. So what you'll do is, as you're thinking of your questions, please type them into the questions box, and then I will address them after I finish running through the presentation. So as these come up, just basically enter them in, and then I'll address them as I can. So today's topic is, again, the cost of carbon. It's the ongoing series, and if we think about it, it's a really timely day to do this because this is actually the one-year anniversary of Superstorm Sandy. And I don't know if any of you have been affected by this storm, but I know it had impacts here in the Philadelphia area back when it hit last year. There was a lot of people without power. There's a lot of people that lost their lives, huge property damage from that storm. And the one thing that I hate to say is that I do think that, the effect that all of us are having on the carbon cycle on the planet is most likely contributing to some of these wicked storms we've been seeing and changes in weather patterns and different things. I can't say that we're the only cause, but I can definitely say that we, as through our industrial processes, driving our cars, making electricity and different things, we're definitely affecting the carbon cycle and adjusting that, which is in turn having some effects on weather patterns and temperatures and different things like that. We also know that this is really a global challenge. This isn't just a challenge here in the United States. It's something that we have to deal with globally. The Earth is a closed system, so something that's happening in China can have an effect on us. Something that's happening in the U.S. can have an effect on other people. And if you look at the images on this slide, I don't know if you've heard in the news recently, but in China right now, the air quality is really horrendous in many areas because of weather patterns there. There's just this ground level smog that's basically stuck in these cities and these valleys and really affecting people's health, productivity, the ability to do things. And a lot of that is related to the way power is generated, as well as industrial systems and transportation. We do generate a great deal of our energy from combustion and burning things. In this particular example, you see here a large coal pile. And unfortunately, in places like China, coal is one of their primary sources of creating electricity. It's very abundant in that country. They have a cheap labor. They can mine it. So there's just a tremendous amount of activity around burning coal to make electricity. In fact, my understanding is that there's about one coal-fired power plant coming online each week in China as they try to fuel their industrial growth. So there's a lot of things we have to think about, global issues to deal with. The effects that we're seeing can be illustrated in this slide. And I really like this slide because if you think about a carbon budget, all of us are responsible for generating about 8.7 billion tons of carbon each year, releasing that into the atmosphere. And that was how I made my statement about we're affecting the carbon cycle. The Earth and all the natural systems that can actually capture and sequester carbon can take up about 5.3 billion tons. So if we do a simple math problem, 8.7 minus 5.3, that's about 3.4 billion tons of excess carbon a year in the form of CO2 and other gases that are released into the environment. And we're seeing an increase of about 2 to 3 parts per million per year in the overall CO2 levels. And as you can see here, if we just look at various levels over the last year or two. 2011 we were at 389 parts per million. Now we're up to about 393. And the thing we have to think about is trends, and this is where a lot of the discussion comes in around, are we really having an effect, and are we altering a carbon cycle? And this graph really illustrates it well. Now, NOAA, National Oceanic and Atmospheric Administration, has done sampling of ice cores to try to understand what have been carbon levels over the last 800,000 years. Not a perfect science, but it's the best measurement we have. And as you can see, the upper limit was typically not more than 300 parts per million, but that was over 800,000 years, and there was always variation. So we should expect some normal variation in carbon levels or CO2 levels. But if you look at this very short amount of time that really looks at our industrial revolution, which is only the last few hundred years here, we've had a major increase in CO2 levels, and as you know, we're almost at 400 parts per million in just a short amount of time. So this illustrates how we are really affecting the carbon cycle, and definitely creating issues. In the blog, if you watch the blog, we already talked about a lot of different types of carbon emissions that we want to measure. Scope 1 are definitely from burning fuels. So if you're burning natural gas in your building or your home, or you're burning gasoline in your truck fleet or your vehicle fleet, this is Scope 1 emissions, and you're directly responsible for those emissions. The organization is responsible and will capture them. But then we also have to look at things like indirect emissions, and that's really based on the electricity that all of us use. Everybody on the phone here uses electricity. We're using it right now for this webinar. So we're all responsible for that. And imagine, a large manufacturing company or a big office building. There's definitely a lot of energy used, a lot of electricity. So understanding how much we use and where it's generated, the type of grid mix, is really important, and I'll talk about that in a second. So Scope 1 and Scope 2 are the primary areas of measuring carbon footprint right now. Scope 3 are other indirect emissions that we look at, and that's actually a science that's coming along pretty well. There's some companies that are actually measuring this, a lot have not. I did look at the attendee list, and I know some of you that are on this call right now have already done some carbon footprinting. You know what your Scope 1 and Scope 2 emissions. Some of you may not have, and you're wanting to learn how to do that. But Scope 3 is another area that does need focus. And, first I think it's really imperative that we focus on Scope 1 and Scope 2, get our handle on that, and then we can start to zero in on Scope 3. And that includes things like business travel, transportation distribution, purchase goods and services. For any of you that are on the phone that are direct suppliers to Walmart, Walmart is actually measuring, if you're reporting to the Carbon Disclosure Project, Walmart's actually trying to understand what they're responsible for as far as the goods and services they purchase as an organization. So they're really looking at Scope 3 emissions there. So just to give you a background on what scopes to focus on, we also have to remember that CO2 is not the only gas. There's also methane, nitrogen oxides, various other things, HFCs, different other gases that contribute to carbon footprint and global warming and different things like that. I also talked about in the blog about using the e-grid, and two important points I want to make here is if you look at various areas around the United States when you're measuring Scope 2 emissions, this e-grid matrix is really good to understand how electricity is generated in your particular grid region. Is it heavily based on burning coal or oil, natural gas? Is it based on hydro or nuclear? And if you look at the different regions here, RFCE, for example, if we look at that, we can basically understand, what our RFCE is, RFC East, and you can see here it's 0.95 CO2 equivalents per kilowatt hour utilized. And basically, I know for a fact that this particular region has a lot of nuclear. There's definitely some coal and oil-fired plants in here, natural gas, but nuclear is pretty heavy. Now, if you look at a region that has a much higher impact, like SPP North, 1.82, I can pretty much guarantee that a huge amount of the generation there is related to burning coal and a lot less nuclear and hydro. So, number one, understand where you are. We have people on from all over the world on this call right now. So unfortunately, I only have the eGrid for the United States, but if you're calling in here from another country, it's really good also to try to see if there's similar information that you can find what the grid mix is in your particular country, where you're generating, where you're basically doing your calculations. Another important point about this map is it's also important when you're thinking about reducing carbon footprint is to know what climate zone you're in. And down here in Florida, definitely hot, humid climate. Over here in the Southwest, we're definitely looking at hot, dry climate, desert areas, so a lot of cooling energy. But up here in Michigan, Minnesota, different places like this is northern climate, so there's going to be a lot of heating required here. So just understanding, what climate zone you're in and understanding how you're using energy is a really important aspect of figuring out how to reduce your carbon footprint. Another thing that I wanted to point out is I mentioned Walmart and how they're, basically evaluating many of their suppliers. Walmart is only one company out of many that are doing this. So for those of you that are on the phone here that are actually manufacturing something and having to report, or you're in the supply chain, reporting to the Carbon Disclosure Project is one way that companies are trying to understand what they're responsible for as far as their overall carbon footprint. They're learning about their direct emissions, the electricity they use, but then they're also trying to say, okay, what have we done, as far as the products we purchase and the supply chain we have. I know Tesco has done this as well in UK, and they've done a good job of really trying to understand what various products are contributing to their overall carbon footprint. So now let's talk about the meat of why we're on the call today, is to really dig into about how to reduce carbon footprint. Measuring it by far is one of the most important things you can do. So we've given you some guidance on how to do that. I strongly encourage all of you, whether you work for a large organization or even if you want to do your own personal carbon footprint measurement, you could easily do that with a spreadsheet. If you know how much, personally, if you know how much electricity you use, how much natural gas or other fuels, if you know how much gasoline you burn, you can calculate your carbon footprint by, using a spreadsheet, or there's carbon calculators online. If you're a large organization that has to worry about many facilities, we have companies we work with that have 700 or 800 facilities within their company, and they're trying to look at their overall carbon footprint. That gets a lot more complex, and there are softwares available. There's also spreadsheet systems you can do that as well. But understanding, really important, and once you know how much energy you're using and what you're responsible for, both electricity and fuels, then you can start to really dig in and understand what can we do to reduce these impacts. We strongly encourage companies to do sustainability assessments. This is something that we've been doing for years, where we'll go in and we not only evaluate energy consumption of a company, but we'll look at their waste generation, their raw material usage, basically understanding material flows in the plants or in the building, looking for opportunities to reduce waste. And you have to understand, when you do this, it's really all about having an overall picture of what your footprint is. Energy is important, of course, but also knowing that your water consumption is connected to energy, your waste generation has a connection to energy, and carbon footprint, because if you're generating waste and it's being trucked off site, even to a recycler, there's a carbon footprint associated with that. So the sustainability assessment is a really great way to get a really good picture of what you're doing in your overall organization, or in your building, or in your home, however you want to look at this. Next thing that's critical, and understand also that in order for us to really reverse where we're going with the CO2 emissions and the cost of carbon that we're having on the planet and the environment, it's going to take some radical change. That's not going to happen quickly. So my philosophy is we need to make change on things we can do right away, and that involves what I call aggressive conservation and energy efficiency. So reducing our consumption of electricity, reducing our consumption of fuels. If everybody on this call makes some changes, that's going to add up to a decent size impact till we can figure out how we change our system of electricity generation, which is really big and complex. Maybe in the future we'll start sequestering carbon or capturing carbon out of power plants. There's a lot of research on that right now. So aggressive conservation starts with off. Off is definitely the most effective energy conservation measure that we can do. Establishing a comprehensive energy management program for people that are managing large buildings. It's really understanding how you use energy in that building. Is it on HVAC? Is it on lighting? Is it in the manufacturing process? And once you have a handle on that, you can start to work to reduce consumption. And this graph, this triangle pyramid that we show on the right here, is basically our philosophy: understanding what we can do, implementing low cost and no cost measures right away, addressing plug loads. That means turning off computers, turning off equipment when it's not in use, working on lighting upgrades, water heating, HVAC, and process. And then the envelope is usually the most difficult thing to deal with in a building. It's really hard to add insulation to a wall or change windows. It costs a lot of money. So as we go up this pyramid, the complexity and the investment gets more complicated. One area that I think is a huge opportunity is waste heat recovery. There's so many BTUs that get wasted in manufacturing plants or in different operations. In fact, some of the most efficient power plants right now for generating electricity use combined cycles where they're capturing heat out of stack gases and they're generating more electricity. We've been in a lot of facilities where we can capture waste heat, for example, off an air compressor and use that to heat a building or heat a space. We can capture waste heat coming out of a boiler stack and use it for heating water. So a lot of opportunities there. Depending on what you do, what type of company you're working in, that's an area that you definitely want to look at. Heating and cooling systems is another big opportunity. Just turning off equipment when it's not in use. I drive around all the time. I'm coming home from teaching at night or a meeting, and I drive by a big office building, and every light in the building's on. There's no cars in the parking lot. Nobody's in that building except maybe one person cleaning, if anybody, and it's just a huge waste of energy. So that's why I say off is a really easy thing to do. And then there's really complex things we can get into as far as evaluating things that require capital and different things like that. So another area that I also want to talk about for anybody that's on the phone here that is manufacturing products, really using life cycle assessment to reduce impacts on products is really important. You can also understand the impacts of your operations by running a life cycle assessment. Life cycle assessment basically looks at impacts of a product, service, or operation from cradle to grave, or better yet, cradle to cradle as we go to a closed-loop economy, and understanding raw materials, understanding transportation, manufacturing, distribution, product use. So it's really looking at the whole life of a product. This example I show here is actually a spider graph. So in this particular product, we had done a life cycle assessment of the product to understand all the impacts. And global warming, you can see, is at the top of the pyramid, but we can look at other impacts like acidification or smog or ozone depletion. And what we did is once we understood those impacts, we worked with this company and their new product development people to redesign the product, to make some improvements in the manufacturing process, and just to make some changes. And then they basically implemented that. They added recycled content to the product. They improved some processes within the plant. They started capturing some waste heat. They did a lighting retrofit. They turned off equipment when it wasn't needed, had a big reduction in electricity use and gas consumption. We ran the life cycle assessment in our software, and we noted that we had a reduction of about 30% in global warming potential for each kilogram of this product. So you can see here that there's awesome opportunity around product innovation to reduce our impact from a global warming perspective and from carbon emissions. So of course buildings are important, but using this tool of life cycle assessment to really assess products is really, really key. So once you've done a great job of reducing and conserving and reducing your energy aspects, the next thing you want to do is consider renewable sources. Now I know that renewable energy can be expensive. Sometimes it doesn't make sense from an economic standpoint. You do have the ability, though, to buy renewable energy credits. You do have the ability, even as here in Pennsylvania, if we wanted to buy renewable power, we have that choice. We can select companies that provide us with wind or solar power. Even big companies can do that. But there are opportunities to really think about how can we integrate renewables into existing and new buildings, and these are two examples right here. On the right here, you can see a solar system that was we designed and installed on a building down in Philadelphia. This is an 80 kilowatt system. It's on a federal courthouse building, and the system's been performing really well. It does offset maybe 10 to 15% of the total energy in that building, but that is a 10 to 15% reduction in energy usage. Here's another example of how you can integrate something into your own home. Here's a solar shading structure that we designed, and basically you can see it's integrated right into the infrastructure of the building. It actually serves as part of an outdoor living space, so this not only generates electricity, but provides value in the fact that you can utilize this space for entertaining or just enjoying the outdoors. A lot of different things you can consider when we look at reducing carbon footprint, and renewable energy systems are definitely something to consider. You can also think about wind. You can think about going with geothermal, depending on what region of the country or the world you're in. And when I say geothermal, I'm talking about capturing energy or heat out of the earth. A lot of times people put in ground source heat pumps. We call that geothermal as well, and that is an efficient way to heat and cool a home or a large building. But true geothermal is where we're capturing steam or energy out of the earth. So I know we don't have a lot of time today, but I just wanted to give you an idea of how you could reduce your carbon footprint. And like I said, first thing is really measuring. I do want to mention that if you are enjoying learning about this, ultimately what we're trying to do is continue this blog series. The next one we're going to be doing is called Benchmarking and Measurement, evaluating where you are, determining where you're going. And ultimately what we're going to be doing is having a seminar on May 7th, 2014. It's going to be here in Philadelphia at the Hub, and this will be a program to really focus on corporate responsibility, and we're calling it Corporate Responsibility Revolution Strategy to Success. It's going to be a hands-on, action-oriented workshop where attendees can actually work to develop a corporate responsibility plan that they can leave that day, take with them, and go implement it wherever they work or into their lives or whatever they want to do. And to find out more about this, it's going to be on my seminar section of my website, or you can contact me directly. We do have very limited space for this, so if you are interested, I would say definitely make your reservation because it is something that will be coming up really quickly because May is not that far away. So now let's take some questions and see what people are wondering about here. Looks like we've got several. So the first question here is, for a business with many buildings of similar size and layout, what is the best way to begin understanding building carbon footprint to develop carbon reduction initiatives down the road? Well, if a company does have many buildings, like I said, the first step you would want to do is benchmark the buildings. You can do that in Portfolio Manager. That's a really good way to do it if it's a straightforward building. Or ideally, if you do have a spreadsheet system or some type of software that will do your carbon footprinting, you would enter your Scope 1, Scope 2 emissions, understanding what your grid region is, and then basically evaluate those buildings, understand the total amount of CO2 equivalent carbon emissions that are coming out per building, per square foot, per person. And then from there, ideally what you'd want to do is do a assessment of how you can reduce energy in those buildings. And if you're looking at, say, a large portfolio of 10, 20, 300, 700 buildings, ideally what you want to do is assess some of those buildings, find out what common opportunities are, and then establish like a plan or a program that you can implement across the board. And you'd have to, again, consider different climate zones, different building uses, different things like that. But that would be probably the most effective way to attack a whole portfolio. And there are ways to measure that. The next question that I got here says, how many companies actually do the Scope 3 emissions? Well, that's a hard question to answer. I do know that, say, 2 years ago, a lot of people that were trying to respond to requests from Walmart or Tesco, most of them were really focused on their Scope 1 and Scope 2 emissions, and they were just basically getting their carbon disclosure project submissions completed with the plan that they would eventually start moving to a direction where they would start measuring their Scope 3. And Scope 3 is complicated because you got to really understand how your employees are commuting. You got to measure business travel. You got to really look at your suppliers. So, it does get complex, but I do know there are a few companies out there that are doing it. Again, Walmart is a good example, but I would say that the majority of them are not. And for most of the people on this call, depending on what you're working on or your focus, this is an area that you can definitely implement and consider. Okay, I've got another question here. How do you recommend we track company performance when we are buying and selling a lot of buildings, making it hard to compare apples to apples? Well, that does get complex. And again, the first step is getting data. So if you do have multiple buildings, you definitely want to be measuring that energy consumption and tracking that right away. And then keeping tabs of that, and typically what you're going to look at is, say, 1 year of time frame. So let's say you look at 2013. The easiest thing to do is benchmark yourself to 1 year, and if you are buying and selling buildings in that time frame, you got to look at net buildings, total buildings that you started with, total buildings you have at the end of the year, and then basically measure the carbon footprint there. And if any buildings were sold in that year, you would maybe subtract them out or have some type of multiplier to know that that percentage of your carbon footprint was reduced for so many months. And you could basically do that based on an average. One other question, where do I start if I want to conduct an LCA on a product? Well, the first thing you would do is you need to understand the product. You need to understand all the raw materials. And there are people out there that can help with that. There are softwares you can purchase. It just depends on how in-depth you want to go. Some companies like to do it in-house. Others do hire consultants to help them with that. And that is something that we have been doing here at Sustainable Solutions for a long time, and it has been very helpful. But we've also helped companies that want to do it in-house to train their people and to get them up to speed on how to go about doing it. So looks like we have about 1 more minute here, and we had one other question around renewables. Do we see the possibility that there might be a reduction in cost of, say, solar panels in the future? Well, solar panels have definitely been coming down in price. The ideal thing we really need is some type of program to help drive the use of renewables on a national basis. Some states have had programs, like here in Pennsylvania, they have the Sunshine Grant program where people could get money for installing renewables on their buildings. But ideally we need something that's more national and would help promote and encourage the use of these. And I also think one way to do that would be to put a fair price on carbon, which is something we don't really do. Most of the costs of carbon are externalized. If a company's burning coal to make electricity, the cost of extracting the coal, the impacts of all that, the cost of all the fine particulates that are creating asthma and other diseases in people are externalized. And if you're paying 6 cents a kilowatt hour for electricity out of a power plant, in reality there was a huge environmental cost to that that's not captured. And that's something we'll be talking about in future blogs on how we try to capture that and maybe how we fix the system. So it looks like we're coming up on the end of time. I think I've answered all the questions. I really appreciate everybody joining. Again, keep following me on the blog. The more of you that ask questions, the more I can tailor these different blogs that I put together and the different topics we'll cover. And again, keep in mind that we are having the seminar coming up, and every month we'll be doing one of these webinars, and each month we'll have a different focus for the blogs. And I do try to keep them short because I know you're all really busy. So again, thanks for all joining. I appreciate your time, and I look forward to seeing you on future webinars, and keep your comments coming in. Thank you, and have a great day.